In the PLC, inputs will have connected sensors such as thermometers, flow meters, pressure sensors, and etc. In the PLC outputs, it will have connected lights, electric valves, motors, and other actuators. The PLC reads the inputs and evaluates these values in the program that is stored inside of the CPU, then the PLC updates the status of the outputs. At the final, all of the information can be transferred remotely to the control room where is monitored and analyzed. Day by day, many companies are leading to advanced technologies in the development of new controllers PLC. Every company will provide various and different functions and features. The most famous PLC brands around the world are Allen-Bradley, Schneider, Mitsubishi, Omron, Siemens, Bosch, ABB, Hitachi, Honeywell, Delta, Faytech, and General Electric. According to the application, we can find PLC dedicated for basic applications with smart relays such as Siemens Logo series, Schneider Zelio series, and Omron Zen series. For simple machines application, we can find Delta DVP series, Schneider Twido series, Siemens S7 series, and Allen-Bradley Micrologics. On the other hand, for more complex applications with middle number of inputs and outputs, we can find controllers such as Schneider M340 series, Siemens S7 series, and Allen-Bradley Compact Logic series. Finally, for critical applications that requires high number of inputs and outputs and redundancy, we can find Schneider Premium series and Siemens S7 400 series. Another important device within an automated system is the HMI, that stands for Human-Machine Interface. Before the HMI came into existence, a control might consist of hundreds of push buttons and LEDs performing different operations. HMI is a device for user interface or dashboard that connects the operator with the whole system. The HMI provides a visual representation of a control system and provides real-time data acquisition. It is a centralized control center that is user-friendly. It is suitable for applications that require constant feedback and monitoring. In the first picture, it shows an application where the HMI is installed on a cabinet. The pre-assembled seals allow high IP protection against water and dust without big effort. In this way, the panel can be manipulated without a risk of damage. In the second picture is the installation seen from inside of the cabinet. The system as a whole can then be fixed with 8 screws from the inside or with clamping screws versus the front panel. This design type features extreme robustness and is particularly suitable for quick installation. This is an application of a manufacturing line monitoring system, which allows the operators to monitor everything on the factory from a centralized room. The Industry 4.0 solution enables operators to acquire data at different stages and stations of production. In this application, every station contains different sensors such as switches, light towels, and analog signals. The PLC takes all this information from the sensors and transforms it to digital signal, so the HMI can decipher, make decisions and show the results on the screen. The advantage of developing in Smart Factory is that operators can predict machine failures and brings higher operational intelligence. Finally, it is possible to connect multiple production lines and machines with each other. Now, we will give a general concept about electricity. Electricity is nothing but the movement of electrons through a conductor, like a wire. In the below picture you can see how does the electricity flows in two ways, either in direct current, DC, or in an alternating current, AC. The difference between AC and DC lies in the direction in which the electrons flow. In DC, the electrons flow in a single direction, or forward. In AC, electrons switch directions, sometimes going forward and then going backward. The advantage of using alternating current AC is that it can transmit electricity over large distances, such as for household use. Converter and inverter are two concepts that are easily confused, however we will make a comparison between the two. The converter is an electrical device that converts the voltage from alternating current, AC, to direct current, DC. The converters are fundamental part of most of the electronic devices. The inverter does the opposite work. It converts the voltage from direct current, DC, to alternating current, AC. The below application starts with the solar panels collecting the light from the sun. The circuit of the solar panel is coupled to the inverter that converts the DC current into AC. Later this energy can be used in a house to turn on the lights. Now we will also explain the difference between a motor and a generator. The motor converts electrical energy into mechanical energy. For this, it uses electricity to work. The motors are used for pumping water, automotive, conveyors and lifting. In the below application, the motor is coupled to a pump to extract the water from the river, and provide the house with water. On the other hand, a generator converts mechanical energy to electrical energy. Thus, this device generates electricity. They are usually used for applications where there is a lack of energy. In the below application, the garage may be located far from the house and with no electric installations. The portable generation can be employed to turn on the motors, and open the doors and let the car get inside. Combination of AC motor with inverter. Homes, office buildings, and factories are supplied with AC electricity at various frequencies and voltages such as 50 Hz and 60 Hz. But AC motors are constant speed devices. So, how can we modify the motor's speed according to our applications? In the electrical field, we can take advantage of the inverter. It will change the input voltage or frequency, which directly modifies the motor's rotation. Without an inverter, the AC motor would operate at full speed as soon as the power supply was turned on. With no change of speed, applications would be limited. This type of control, in which the frequency and voltage are freely set, is called pulse width modulation, or PWM. The inverter first converts the input AC power to DC power. The second step, the inverter creates a new AC power using PWM control. At the final, the inverter provides to the motor a controlled power that suits any application. Finally, we will talk about the controllers CNC because nowadays are widely spread in the industry. CNC machining is a process used in the manufacturing sector that involves the use of computers to control machines' tools such as lathes, mills, routers, and grinders. The physical movements of the machine are controlled by instructions, such as coordinate positions that are generated using a computer. CNC is typically used to refer to a device which uses a rotating cutting tool which moves in 3 or more axes, X, Y, and Z, to cut out or carve parts in different types of materials. The advantages of using a CNC are high repeatability and precision, high volume of production, machining of complex contours surfaces, more safe, higher productivity with higher quality. But it also has some disadvantages such as costly setup and difficult maintenance, requirement of hiring skilled operators to program the computers. Here, we introduce the most representative CNC machines. Milling, most widely used CNC machines, predominantly for drilling and turning metals. Lathes, for production of 3D shapes or molds. Routers, used for cutting complex or intricate shapes and prototypes. Plasma and laser cutters, utilized for cutting 2D shapes and molds. Web Access CN molds. Web Access CNC Advantech solution. With the evolution of industrial automation, machines nowadays are becoming smarter and more digitized. To accelerate the implementation of smart machine monitoring and management in Industry 4.0 applications, Advantech's CNC machine management solution plays a critical role in IoT integration from edge computing to cloud-based services. A solution of this type starts connecting the instrumented module and equipment that is located in the field site. Later the information is transferred to the WISE-PaaS cloud service using the edge devices that work as a gateway. As a result, Advantech offers an intelligent CNC management solution has been developed to bridge the gap from traditional machine management to optimization. Thanks for watching this training video. You are welcome to keep watching the next one.